Hi everyone, and welcome to the Percentages Study Guide video. So in this video I'm going to be walking through the Percentages Study Guide, and I'm going to go over the examples, talk a little bit about some of the reading that you have to do here in between the examples, and then also, when appropriate, bring in some of the other resources we have. So percentages for us, there's a lot to the study guide, but it really all boils down to one equation. And so I'm going to introduce a few different types of problems we can solve by using the same equation each time. It's just we're going to have to think about what we're given and how to use the equation to solve that. So there's another way to solve these problems, and I have resources for that path that you can take as well. And so if you go into Lumen, you'll see that there's a document called the Percentages Quick Sheet. And so the idea here is, in this lecture guide, we're going to use one equation to solve all the problems, okay? But you could also go this other way where, you could kind of take every one of these different problems we're going to do, and you could break them up into these kind of separate equations. And basically, it's the same thing either way. It's just kind of how you think about it. And so if it's easier for you to read a problem and go, ooh, percent increase, I just want to use this formula where I take the big number minus the small number divided by the small number times 100. Like, I just want to do that. Okay, that's fine. You could do that. I'm just going to do it a slightly different way. But, if you want to use these formulas over the way that I'm going to do it, that's fine. If you see a different way online, watching a video, reading something, and you can get to the same answer, but it's a different way to formulate your work, awesome. That's great too. If I don't ask you to use a specific way to solve something, like if I just say, here's a problem, solve it, you can use whatever way you want. As long as it's mathematically valid, it doesn't matter to me. Okay, so just have that in the back of your mind. If we do something a certain way in a video and you're like, I like this other way better, use the other way. Okay, so let's get back to it. So like I just said, for percentages, it's all going to come down to one formula. And that formula is right here. And it's y equals x times p. Okay, so I have that written in words above. Y is the new number. So whenever you're doing a percentage problem, you've got some old number, a starting number. You multiply it by a percentage, okay? And then you arrive at a new number. So again, I have an old number. I multiply by some percentage, which we usually turn into a decimal, right? So this thing is going to be in decimal form. So right here, this is going to be in decimal form, right? No more percent sign, just as a decimal, and we'll practice that. And I'm going to multiply it by the old number to get the new number. That's percentages. 20% of an old number gives me a new number. It's okay, so that's it. Sounds simple, right? Well, depending on the way I give you information, you might have to reformulate this. And so I've given you three forms here. And so the idea, options or forms I said in the weekly activity, I give hints of forms. So these are the three forms. Form number one says, I know the new number and the old number, but I don't know the percentage p. I don't know what the percent is. And so what does that look like? Well, here's an example. 10 is what percent of 50? Okay, so what do? I say, okay, 10 is my new number, so that's why I plugged it in for the new number here. 50, that's my old number, okay, and then P is my percentage. I don't know this. I got to find that out. So what do? And every time we're in this form, it's awesome. It's the same idea. So I've plugged in. I just now have to solve for P. So this goes back to our algebra. What do we do to solve for a variable like P? We just take all the other numbers and we move them away. And the way you do that is you have to do the opposite. So when I'm looking at this, I see, okay, 50 is attached to P. So I'm right here, right? 50 is attached to P using multiplication. What's the opposite of that? Well, the opposite of that is to divide. So I divide. And remember, if you're going to do it to one side, you got to do it to the other. Okay, so look, I've got 50 over 50. Awesome. Those cancel. And that's what I wanted. I wanted it gone. And so I end up with P equals 10 over 50, which is 0.20. And remember, how do I make this a percentage? Right? How do I go from here to here? I've got to move the decimal place 2 to the right. So I took 0.20 and then I went, okay, 1, 2. That gives me 20%. All right? So then it has a sentence now. 10 is 20% of 50. And we got it. So that's form 1. I know my new and old. I don't know the percent. Well, what else could happen? Well, I could know the new number y right here, and I could know the percentage that I'm using, but maybe I don't know x. So here's a form of that. 20 is 50% of what? So this is telling me I don't know my starting point. All right, so I'm going to convert this into the equation here. I know 20, my new number. I know the percent. I don't know my old. And we end up seeing something pretty similar to what we had here. I need x now, but it's still being multiplied by a number. And so what I can do is say, well, I don't want that 0.5 anymore. Get rid of that. So, okay, let's do it. We're going to divide to get rid of it. Put it over here. And when I plug this into the calculator, what's going to happen? I'm going to end up with x, because remember, these cancel, right? Go away. I end up with x is 40. 20 is 50% of 40. Think about that for a second. 20 is half of 40. Oh yeah, that works. We've got it. All right, so form number 2. I know my new number and my percent. I don't know my old. Form number 3, the only one that's left. I know my start. I know my percent. I don't know the new number. What am I going to end up with? And this is actually the easiest one because there's no solving that has to happen, right? Right over here, there's no extra variable. I know I start with 40. I know I'm doing 80%. So we get 80% of 40 is what? That's this equation. Nothing fancy here. Multiply these two numbers together. I get 32 right here. 32 is 80% of 40. And so pretty much every percentage problem we're ever going to run across is going to end up in one of these 3 forms. What you're going to see in the next page is that we can kind of add a layer to the way we talk about percentages. But the really neat thing is it doesn't matter. Even if I try to add on top of a problem like this, I still end up in 1, in 2, or in 3. Every time I end up there somewhere. I end up with an equation that looks just like one of these. I don't know P, or I don't know X, my start, or I don't know Y, my finish, my end number. There you go. So stop here. Try some of the weekly activity problems that go along with this. See if you can get them. See if you can feel comfortable. Again, if you prefer to try to use the other formulas, right? If you instead try to use the other formulas to fit them into different places here, or you watch a video and you're like, ooh, I like that one better, go for it. Totally fine. But I think doing it this way means I have to remember less. Look, one formula. That's it. You only have to remember one thing. New number equals old number times percent. The only work comes into reading a problem and going, what thing don't I know? Do I not know the new number? Do I not know the old number? Or do I not know the percent? Okay, so let's move on. Let's get down here to the next piece. So the next piece of this is specifically talking about percentage increase, decrease. So the kind of tricky thing here is we actually have already been doing this a little bit. All 3 of these problems that we just went over were I was decreasing by a percent. What's decrease mean? It means to get smaller. So what happened? 50 in this example got smaller to 10. It decreased to 10. In this example, 40 decreased to 20. In this example, 40 decreased to 32. So we actually have done this just 3 times already. But what's different now is I now want to talk about, instead of 32 is 80% of 40, how do I talk about 32 in terms of a percentage decrease from 40? Okay, so that's a little bit different. I know it sounds like I just said the same thing, but it's a teeny bit different. And we'll do an example to show you kind of what I mean by that. So let's get down here and let's talk about this. So again, we just got a bunch of smaller numbers. And here's the neat thing about this. Without thought going forward, this all comes down to P in my equation. Really important right here. If P in my equation, and don't forget, I'll just rewrite it here. This is what I'm talking about when I say my equation, the equation, times P. If you get to a point like this and your P that you find is less than 1, so 0.8, 0.2, 0.5, what we just dealt with, you are talking about decrease, okay? So that's, as soon as you see a P less than 1, you're, boom, I'm taking a number X, I'm making it smaller, getting to Y. Okay, so, okay, well, what's new then? You might be saying, like, all right, well, what the heck's going on here? What's new? Well, in order to understand it, let's try this question. And what I would tell you is, before you reading any more, stop with this green question mark. Probably should have made it red, right? Stop with the green question mark and try to answer the question that comes next. What number is 10% less than 80? Okay, and so, again, you go to this other sheet, right? You might see all of these different things here you could try. So a new value after some A% decrease. And so you got this formula here that you can try using. But what I'm saying is, you know what? Get out of my face, you quick sheet. I'm saying I don't need that, okay? I can do this just with my equation here. But I've got to think about what I'm doing. That's the whole key, is if you want to go this way with me and use the one equation, you got to think about what is going on. 10% less than 80. So try that. Pause the video. Try to see if you could figure it out using just this equation. Okay? So you paused. I'll wait. Just kidding. You would pause, not just sit with me. All right, we're back. You've tried it out to see what you get. So what I've done here, starting right here, is I just tried what I think is, if you're not sure about this at all, the most natural way to do this. So right here, I tried what I think is like just the most natural way, because I gave you a percent, so I think it's very natural for you to go, okay, Mr. B gave me a percent, P is percent, let me just plug it in. And so, okay, here, let's do that. Let's try it, right? Let's just try. Y, the new number, is 80 times the 10%, again as a decimal. Okay, so does this work? Let's write that out. Let's finish this. This equals, if you plug this into the calculator, 8. So if you think that that's true, right? If you think this works, let's stop and think. What we're saying is that 8 is 10% less than 80. That's what you're saying if you think that equation is right. So let's think about that. 10%, that's pretty small. I want to take 10% away from 80. So say it out loud. I want to take a small percentage, small amount away from 80. What should I have left? I should have something pretty big still, right? I only took away 10%. That's small. I should be left with a lot. But wait, 8, that's really small compared to 80, right? This 8 here, that's way too small. That's not 10% less than 80. That's 10% of 80. So I get that that's tricky because I'm changing, what, 2 words? But you got to really pay attention to what's being asked here. I want what's 10% less than 80. This equation, if this is what you tried, gives me 10% of 80. And these two things right, here and here, these are not the same. Not the same. So be super careful. 10% less than a number is not the same thing as 10% of. Okay? They're in some way opposites that you'll see in a little bit. So maybe this was a good try, but not quite. Although, you know, if you plug the 10% here, you're closer than you might think now that I've said, right? So let's just kind of this doesn't work. But you know, let's go through. Let's see. So this is where it gets a little tricky because we don't just have a number to plug in. The 10% is useful. We need it. But what we need to do is figure out what p is. So how do we do that? And it's pretty neat. It works the same way each time, and you'll get quick at this once you practice it. So I know it might seem like it's taking a while, but once you kind of get to this, it'll be like boom, boom, boom. Not bad. So what does this say? It says to find the percentage I should use, we need to ask this question. If I take away 10%, what percent is left? So what do I mean by that, right? If I have, 100% here, I got all of the 80, and then I take away 10%, what percent is left? Well, 90% is left. So here's the trick. I've just tried to trick you with this question. When I say what's 10% less than 80, I'm trickily just saying what's 90% of 80. We know how to solve that. Take your percentage, plug it into p, multiply by 80, right? This is form number 3 above. I know my start, I know my p, I don't know why. I was just trying to trick you a little. That's it. You take your 90%, the what's left over, you multiply by 80, and you get 72. 72 is 10% less than 80. Boom. So there you go. That's it. How do we solve these percent decrease problems? You take the percentage that I told you, right, this 10%. You say, okay, how do I figure out how much is left? You can do something like this. You can do it in your head. You can write it out. 100% minus the 10, 90's left. That's what goes into my formula. But again, what happened? It felt like a whole new problem. Nope. It was just the same formula, the same thing as earlier. I just tried to get a little tricky here with the p. And there you go. So try now one of the problems on the weekly activity. Go give it a shot. Try it out. See if you can get there. Okay. All right. Well, what about increase, right? So this is kind of the opposite. What about increase? Well, if we want to be increasing, we need our p to be greater than 1. So in my equation, just to rewrite it, y equals x times p, I need my p to be greater than 1. Okay, so here's a question. Let's just try it. What number is 25% greater than 70? So, So there's a couple ways to do this. And again, you have your own way. Awesome. Do it that way. One thing you might say is, okay, I can do this, right? I can do this in pieces. That's totally fine. Like, how would I do this in pieces? Well, I know that I want 25% of 70. That's going to be important. So you could do that. 70 times 0.25 equals 17.5. This calculation gives me 25% of 70. So what does it mean to say greater? What do I do with that? Well, I want to get bigger, right? Think math, think I got bigger. Think math, think I got bigger. That's addition. So all I have to do is then do 70 plus 17.5. So this works. This is a fine way to do percent increase, and you got it. If you know the start number, You take the percentage of that, like, you might be more comfortable with, and then you plop that on top of your start number. Great, you can do it that way, totally fine. The other way you can do this, tricky, it's the lazy math way to do it, is say, I don't need to do all that extra steps. I can think this through. Instead of doing this extra step, I can just say, I can use my equation, y equals x times p. It should still work. New equals old times p. I just got to think, what is this p going to be? Well, this p has to keep 70. I need to stay with 70. But then it also has to add 25% on top. And the tricky way we do that is, and it's really not bad, we take 1. This 1 represents keep. That's not a very good E. Oh, I just keep doing it. Keep the 70. So don't get rid of any of it. Keep it there. And then the 0.25 here, this 0.25 says add 25%. So we're tricky, little tricky here. You can take the idea of being greater and the percent you want to go up by, and all of it is sneaky in this P here. Just sneakily sitting in this P here. Which is awesome, because then boom, look at that. I just multiplied 2 numbers together, I'm just done. Instead of having to do these extra steps. And I know that maybe these extra steps here, the multiply by 25%, then add, it might seem more natural. That's okay. You can do it that way. But if you really think about what's happening here and you kind of use the shortcut, you get fast. You can go fast through these. Boom, boom, boom. And you can really start to think about what this means and solving many different types of problems just thinking about this one formula. Okay? So try out the problems on the weekly activity. We're going to go through them in class because there's many forms of this, right? So the way that this works with the percent increase is I just gave you, which one did I give you? I said, I don't know why. So let's go back up to our forms, right? That's form 3. So I just gave you a problem here. This problem, so let's write it down. This one here is form 3 plus percentage increase. But guess what? There's a new question I could give you. I could give you one that was form 2 plus a percentage increase. And I could give you another one that's, the problem looks like form 1, but also has percent increase. And so it seems like I'm giving you all these different types of problems, but it's all about one equation. We just got to think about what we know and how we can plug it in. Okay, so we'll go over all these different forms together. But this is me trying to get you to really get those math juices flowing of, I don't need to be memorizing all these equations. I've got one equation for percentages, and I just gotta be thinking, I gotta be a little creative with how I use it. And we can solve anything. So go try those. We'll do some of this in class together on Friday.